Again, the mean is known as the average. As I said a few minutes ago, you could have a population or you could have a sample. The symbol for mean for population is mu. Mu is the mean of the population. X bar is the mean of the sample. Now, everyone seems to be able to do this. I said, if these were your test scores, we had these 3 exams, and these are your test scores. You got an 80, you got a 60, and you got a 70 on the 3 exams. How do you find your average?
Add them all up and divide by 3.
Add them and divide by 3. And is that 210 divided by 3? Which is 70. Your average is 70. So the way we calculate the mean, if it's a sample, we add all the values, summation of all the values, divided by the number of values. N is the sample size. That's what N is. N is the sample size. If it's a population, we add all the values and we divide by the population size. We use capital N for population size. So small n represent a sample size, big N represent a population size. So X bar, the mean of a sample, mu, population mean. Both, you add them and you divide by the number of values. Now, if you notice one thing, if you take these numbers, by the way, the 80, these are your test scores, 60 and 70. And if you subtract from each one the average and you add them, that's what we call measure of center. So this is the score, and this is X minus, let's assume this is just a sample of your scores, X bar. So my average is 70. What's 80 minus 70 here? 10. What's 60 minus 70? Negative 10. What's 70 minus 70? 0. When you add them, what's that sum? Always a 0. Always. Has to be. So if you take the difference between the values in your average and you add them, the sum is always going to be 0. Every single time. Why? Because your average is right in the middle. Halfway between the high values, the above, and the ones below it there. So whatever you gain on one end, you're going to lose it on the other end. So that's the reason why we call it the measure of center. It's in the middle there. What are the advantages and disadvantages of the mean?
The advantage is that you can tell right where the center is, about
Okay.
how much everyone was where.
Okay.
Just a regular level.
I know where you're going with that. I'll give you an example to answer that. But the one nice thing about the mean, you include every single value. You can't leave anything out.
That can also be a disadvantage, too.
What is it?
It can also be a disadvantage if there's.
That's a disadvantage. If you have a high value or a low value, what happened to that average?
Use it.
Yep, exactly. That's really a disadvantage with the mean. If you have somebody fails that test, let's say we get 10 people in the class, and everyone got an 80 on the test. The average is 80. But if one person now gets a 0 on that test, that average dropped by what? 10 points for each one. It looks like, oh, that's a horrible test. Everyone did lousy. So it does actually get affected by high values and low values. What you're saying about the mean, I'll give you this example. I'm not a huge fan because I see teachers do that. They take a test, you take a test with the class, they send you an email. Class average was an 84. Or was it 76? Was it 53? So you get an email from your teacher that says, let's say your score is on the test was a 74. That's your score. But the class average was a 77. Yeah, I didn't do well on that class. Not today. That's not true. That is absolutely not true. You might be in the top, probably 5 students in the class. Or it could be in the bottom of 5 students. Because all that means the class average was high. It could be 2 or 3 people got 100 on it. And the rest of the class didn't do that so hot in the 60s. The hundreds actually pulled these people what looks like the class average. So if there's 10 people in the class and 2 people got 100 and the rest in the 60s, and you got a 74, you're probably the 3rd highest score in the class. And vice versa. It could be really an easy test, or not easy test. Could be like 74. So I did a 74. The class average was a 77, but there were 2 people. Everyone got 100 except 2 people got a 0 on it, and that's when you got a 74, and that's why the average is 77. So in this case, you're not doing that well in the class. You're the 3rd lowest value in the class. Yes.
Now, the higher the number of grades, the more effective is the average, right?
Are you asking the more sample size, the bigger the class size? The higher the class size, yes. So each one is not that affecting the result. So if you have a class of 100 students, that's actually a good size sample, very good size sample. So one person only alter it by 1 or 2. So if 2 people fail it, the maximum you're going to lose is 2 points. But if you have a class size of 20, each one really affected by almost 5 points. So if 2 people fail it, the class average just dropped by 10 points if you have a class 20. So it depends on the sample size, correct. Most of the classes that we teach here are 25, 30 and under in our college here. You go to UMass and you have a class of 600 students. Now, in that case, when you see something like this, there's a lot of people score higher than you because 1 or 2 people are not going to pull it down or pull it up there. But here, when you have a class, we have less than 20 people, if 2 people get 100, that could pull the class average by almost 10 points up there. Imagine if everyone got 70, 71, 72, 73, but there's 2 people got 100. That class average just jumped to 81 probably. You're the same as the rest of the class. Everyone gets 70, 71, 72, 70, 73, 71, 72, but there's 2 people got 100. Take this example. We have 10 students, 70, 71, 72. I'll put them in order. Another 72, another 72, 73, 73, 74, 100, 100. There's 10 people. What's the average for that group? I grabbed the wrong one. 100 plus 74 plus 73 times 2 plus 72 times 2, right? Or 3 plus 71 plus 70. When you add them, the average is the summation of all the scores, which is in this case divided by n. When you add them all, 777 divided by 10, which is what? 77.7. Class average is 77. Look at you, 74. You're the 3rd highest score in the class. But you're thinking because your average is 74, the class average is 77, or your score is 74, the class average is 77, you must be not doing well in the class. You're in the bottom half. It's not. You're in the top half. This is the top half, right there. So the class average and your score by themselves, they don't tell you how well you do in relation to the class. Well, you need to add to that list something called the median. The median is the middle value. So let's talk about the median. So that's the mean. Let's look at the median. It's actually the middle value. But that's only correct when what? When the original data values are arranged in order, either from small to large or large to small. So now I came in and said, oh, these are the test scores for the top, the 10 students at the top, the first 10 students in the class. So I have more than 10. 50, 60, 75, 62, 84, 19. That's not good here. 58. That's good. I'll just give up there. 7 students. What is the median for that class?
62.
Well, before we answer that, let's see. We need to put them in order. It might be 62. It might be the correct one. But first I have to put them in order. So smallest value to larger value. 19 is the smallest value. 50, 58, 60, 62, 75, 84. The key is to arrange them in order first. The middle value, it looks like the 60. The 60 is the number in the middle. So if your average is above 60, you're in the top half of the class. If you're below 60, you're in the bottom half of the class. Every time I do a test in statistics or in math, when I use my math lab, I always send 2 numbers to classes. Your score is the class, 3 values. Your score is, they can find their score, but I said the class average is, and the median is. And that's a better picture. Because if the median is 74 and you get a 77, you're in the top half of the class. If the median is 80 and you're 65, or your average is, let's say your average is 80, but the median is 84, you're in the bottom half of the class. Because half the class scored above that value. Half of the group scored above this number, the other half scored below that number. The next question, you're probably wondering, what happens when you have an even number of values? So I'll put them in order, I'll just don't have to do it. 50, 58, 60, 62, 75, 84, and let's see. Timmy wasn't had to take the test, took the test, he got an 84. What is my median now? We have an even values. It's no longer the 60. Because this has how many values to the left? And how many to the right? 4, it can't be. It's not this one either. This has how many to the right? 3, and how many to the left? 4. So what you need to do, take the average of the 2 middle numbers. The median is 60 plus 62 divided by 2, which is what? 61. And by the way, for median, we use X tilde. Tilde. That squiggly line that you see on top of the keyboard on the left side. So X tilde, which is the median, is equal, I don't know why I wrote 6x there. 61, right? So if you look at the 61, how many values to the left of 61? 4. How many values to the right of 61? 4. The median also is referred to sometimes as the 50 percentile. Meaning what? Half the class scored above that number, and half the class scored below that number. In statistics, that's known as Q2. We didn't get to that in our book yet, or in this class. We have Q1, Q2, and Q3. Maybe I'll jump to that while I'm at it. Q stands for quartile, quarter. A quarter has how much money in the quarter? 25. So if you have 1 quarter, that's Q1, quartile. Q1 has 25% of the values to the left and 75% of the values to the 75, not 57. 75% to the right. Q2, imagine 2 quarters. 2 quarters is what? 50? That's 50% to the left, 50% to the right. And Q3, three quarters, that's what? 75% to the left and 25% to the right. So you start, how do you find Q2? That's your median. Let's say I'll go back to these 2 examples. I want to find Q1, Q2, and Q3. I'll go back to these numbers. So let me start with the first example when I had an odd number. I had 19, put them in order, 50, 58, 60, 62, 75, and 84. What's my median? We said the median is the middle value. Where's the middle value? This one. That's your Q2. Q2 is the median. Now, how do you find Q1 and Q3? Yes?
In between the left side and Q2 and the right side and
So how would I find, would you say, how would I find Q1 here?
would it be 50?
Yes, because this is now the 50 percentile, right? So let's take this and find the median for this one. What's the median for this? That's your Q1. And let's find the median for the top half. And what's the median for these values? That's your Q3. So you start by finding Q2, which is the 50 percentile. So we know that's the 50 percentile. To the left of that, okay, what do we have? That's Q1 and that's Q3. Now, in the second example, when Timmy came back and took the test here, my scores were even. So we found Q1 is somewhere here. Q2, not Q1. Q2 is the median, which is 60 plus 62 divided by 2, and we said Q2 is equal to what? 61. Now 61 is not on the list, so this is the left half of that list. Let's find the median for this half, and that'll be right here. Q1, because that's the 50 percentile, that's 50% of the values to the left. The median of that halfway is going to make it 25 and 25. So Q1 is going to be what? 50 plus 58 divided by 2, which is what? 54. And again, to find Q3, we take the median of that group there, which is 75 plus 84 divided by 2. Is that 79.5? So Q1 is 54, Q2 is 61, and Q3 is 79.5. Notice if you think about it, it's actually any number between these really will be Q3. I could have said Q 76, 77, 78, because if I use any of these numbers, how many values to the left of that? 6, and how many to the right? 2. What's 6 out of 8? 75%. So it doesn't have to be this. Could be any number between this and that, but that's what they're going to be looking for an answer. Just like this, any number between this and that will cut the list to 25% to the left and 75% to the right. But the answer we're going to be expecting in the book is that 54. But it could be 55, could be 56, could be 51, 57, 52. Because if I use 52, how many values to the left? Still 2. And how many to the right? 6. 2 out of 8 to the left, that's 25%. 6 out of 8 to the right, 75%. Do you always get 25% and 75%? No. Because if you have 7 value, mathematically, you will never get 25%. Impossible. So when I pick this one, for example, how many values to the left of that? 1, and how many to the right? 1, 2, 3, 4, 5.
So when you do a division, you're basically finding out how many.
So you don't get that, because mathematically it's impossible when you have 7 values to get 25%. Or 75%. There's no way. Yeah. The nice thing about the advantages of the median is what? The advantage we know it's not affected by extreme values. So if the value changes, let's say by mistake when I was entering Timmy's score, instead of 84, I typed in 184 by mistake. Don't get excited, Tim, it doesn't change anything in the median. The median is still the same numbers. It does affect your average, but your median doesn't change, still the same thing. So if you enter the wrong value, if you have a large or extreme values, big and small, instead of 19, I put negative 19,000. What is my median? Still the same. My mean will be affected, but not the median. Again, the key to finding the median, make sure you arrange the values first. If you don't arrange them, you're in trouble. The next one we're going to be looking at is called the mode. The mode, okay, is the value of values. You could have more than one value. I'll put apostrophe S, a bracket S, could be more than one. That occurs with the greatest number frequency. Greatest frequency. Another way of saying it, which value showed up more often than the rest of them? Which value could be values that showed up more often than the rest of them? So I have these numbers, 1, 5, 9, 11. What is my mode? No mode. Another example, 1, 5, 9, 11, 5. What's the mode? 5 is the mode. Another example, 1, 5, 9, 11, 5, 1. What's the mode? Yep. 1, comma, 5. You have two modes. A lot of times we call that bimodal. Bi is two. Bimodal. Another example. 1, 5, 9, 11, 5, 1, 9 again. What's the mode now? 1, 5, 9. I have three modes. Multimodal, more than one, more than two. So you could have no mode, one mode, two modes, three modes, 4, 5. Which one showed up more often? Here, the 1, 5, and 9, each one showed up twice, more than the 11. The 11 only showed up once. That's why we have modes here. Here, each one showed up once. None of them is a mode.
So if they all show up twice, to go back to no mode?
Nope, there's a mode now because they're more frequent. So if each one showed up twice, we actually have each one of them is a mode because it showed up more than once. Another term you might hear is called midrange. And midrange is defined as the value midway between the maximum and minimum. Values. So mathematically, the mid-range is equal to what? It has to land halfway between them. We take the maximum value we add to it the minimum value and we divide the answer by what? 2. That's what mid-range. Halfway between them. The range is high minus low. That's the range. The mid-range, the value halfway between them. So we're going back to the scores here. We had the lowest score was 19, if I remember. So we had 19, 50. These are the scores. 58, 60, 62, 75, 84, and if I include Timmy another 84, it doesn't really matter. My mid-range here it's the maximum minus the, maximum plus the minimum divided by 2. What's the maximum value? 84. What's the minimum value? 19 divided by 2. Do the math is 51.5. And again, this value, the 51.5, is the value that's halfway between the highest score and the lowest score. Now let's look at this mid-range. Is it sensitive to extreme values? If that number 84 goes to 100, does it change? So it is sensitive to extremes. So it is sensitive to the extreme values. If the low value drops to 0, this changes. If the high value goes to 100, that changes. The nice thing about it's really easy to calculate. So that's the only advantage to it, easy to calculate. But that tells you that's the halfway point between the highest score and the lowest score. So if you score above that, you're good. In the top half of the range. If you score below that, in the bottom half of the range. Now we talked about the frequency, but one thing I forgot to mention is problem like this. Let's say I did a study. We asked people, this is people with kids, parents, or families. You don't have to deliver the kids. You could be adopting them, whatever the case is. We asked them, how many kids do you have? How many kids do you have? We asked families, how many kids do you have? So X represent the number of kids. And this is the frequency. We have some people said to us, I have 0 kids. In a case like this, we know probably, I know I had a student in my class, Matt Forrest, his name, I remember that now, sat in the last row. Comes if we were talking about how many kids in your family, and he goes, 16. I go, huh? Same mom and dad? He goes, yes. I said, how many sets of twins? He goes, none. So that's the maximum I know, in 16. But usually most people have what? Maybe under 8, under 9, 10 maybe top. Some culture, there's always a lot of kids. Middle East people have a lot of kids. Spanish always have a lot of kids. Their culture, the more kids, the better. And other cultures, Chinese, always less kids. Japanese, always less kids. But we'll just go through, we'll say, okay, for how many kids? 0 kids. We have 10 families says I have no kids. 1 child, we have 9 families. 2 kids, the sample we tested, it was only 3 of them has 2 kids. 3 kids, we have 8 people. 4 kids, we had 5. And for some reason, 6 and 7, we didn't have anything. But 8 kids, we got 2. Nobody had 9, the one we tested, and 10 kids was 1 person. That's my study. It wasn't worth putting into classes there. So I did them with single values here, because that's an easy one. I don't have that many options. It's not like it's going to be like so many choices. Let's group them into groups. So how would I calculate the average number of kids a family has? This is a sample. So I cannot use this equation. I can't. This, you can only use that when you have single frequency. I can use it if I want to rewrite the 0 how many times? 10 times. Write the 1 how many times? 9 times. Write the 2 how many times? 3. So some of you might actually do that, so let me get even with you then. Hopefully you're not going to be crazy enough to go and write the 0 100 times, and the 1 90 times, and the 2 30 times, and the 3 80 times, and the 4 50 times. So do we have an equation when you have a problem like this? And the answer is yes. we can use this equation, which says the summation of f times x divided by what? The sample size n, which happens to be the sum of f. We use this one when you have frequency distribution table. So I'm going to make an extra column. That's why I left this one stretching all the way out. And this column is going to be f times x. What's 100 times 0?
0.
What's 90 times 1? What's 30 times 2? What's 80 times 3? What's 4 times 50? 200. What's 8 times 20? 160. And 10 times 10, which is 100. If you add these numbers, 10, 19, 25, 2, 4, 6, 8. If I add all the frequency, what do we have? 100, 200, 380, right? So what's the average here? The average number of kids a family has, based on my study, is 850 over 380. 2.24. So an average family will have 2.24 kids. And that's how we calculate when you have frequency distribution table. But again, sometimes you have a range of values. Going back to that smoking problem, we ask people, how many cigarettes a day do you smoke? Number of cigarettes. So let's, in that case, I might want to put them in classes. We're dealing with the smokers. X equals the number of cigarettes a smoker smoke. And this is the frequency. They're all smokers. So we said from 1, when we did it early, to what? 1 to 5. We have 10 people said, I smoke between 1 and 5 cigarettes a day. 6 to 10, we have 12 people. 11 to 15, we got 18 people. I'll do a couple more lines here. 16 to what? 20, we got 9 people. 21 to 25, we got 4 people. First question, does this look like normal distribution to you? And why?
No. Yeah. It goes up and down.
Notice the value starts low, start to increase till it hits a peak value. Then what happened? Decrease. Yep, that's normal distribution. Only problem with this, what makes this problem different than the previous one, the previous how many kids do you have, we have a number here. But here I have no idea how many cigarettes they smoke. It's between 1 and 5. Your guess is as good as mine. Could be 1, could be 2, could be 3, could be 4, could be 5. I don't know. So what would be a fair value to use for them? The midpoint, you mean? Right? That's what we call them, the midpoint. And if you recall, when we did the frequency distribution table, how do you find the midpoint? You take these two numbers, add them and divide by 2. What's 1 plus 5? Divided by 2? 6 plus 10. Divided by 2? 11 plus 15. Divided by 2? Remember, the class width is 5. You see that? This is 5 more than this. This is 5 more than this. What do you think this number? 18. What's the next one? 23. So when you have a range of values like this, you have to find the midpoint. Now you want to take f times x mid. So it would be 10 times 3, 30. 12 times 8, is that 96? $18 times 13, 234. 9 times 18, 162, you said? And what's 4 times 23?
92.
And if you add all these numbers, I think that's 614. If we add the frequencies, what do we have? 30, 40, 49. Is that 53? That's how many, that's my sample size. That's how many people took that survey. So what's now the average, the mean? It's the summation of f times x over the summation of f. F times x is 614 over 53. We find out the average smoker smokes 11.6 cigarettes per day. 11.6 cigarettes per day. The only other thing left there is weighted mean. Weighted. Now, your GPA, for example, on this college here, when you take a class with us, your GPA is calculated based on the grade that you get and how many credits. The classes are not all 3 credits. So you might be taking a physics class, that's 4 credits. And let's be realistic here. Your grade for that class is what? C plus? Somebody says C plus. Then you say, I'm going to take history. That's 3 credit course. And you like history, you get A minus. Then you take another class. And the other class is what? There's a Google class, which is 1 credit, and you got A. And you got calculus now, 4 credits, and you got a B plus. So when you look at that, it's not just add them. There's number of credits is different. So when we have a weighted probability distribution, that's what we have. The equation we're going to use to get x bar is going to be the summation of w times x divided by summation of w. Let me define the number of credits here as W, because each one is different. That's the weight. So W here is the number of credits. For this class, that's what? 4. For this class is what? 3. For this class, that's what? 1. And for this class, that's what? 4. That's the weight. And the score, the X value for each class, you probably don't know what A, B, and C. So a C plus, I think it's 2.3. An A minus, that's a 3.7. An A, 4.0. And B plus is what? 3.3. So to find your GPA, grade point average for this semester, because these are weighted ones, different values, the weight is different for them. I need another column here. That has W times X. 4 times 2.3. 9.2. 3.7 times 3. 11.1. 4.0. And 4 times 3.3. 13.2, right? When you add them all, you have 37.5. You add the weight here, 4 and 3, 7, 8, 12. 12 credits you had that last semester. So your GPA now for the class, your mean, your average, 37.5 divided by 12. I know it's more than 3. $3.125. You get a 3.125. Now, if every class was a 3 credit, if everyone was 3 credits, equal value here, just got to average these numbers. And that's the common mistake people say. I did my average and I got a higher number. I go, nope. Because when you clear that, if you just add them, 2.3 plus 3.7 plus the 4 plus the 3.3 equals. You divide that by 4. If you just average them, my GPA should have been 3.325. Somehow I lost 0.2. It's not, because this is only 1 credit course. That's a 4 credit course. That's much bigger. It's like taking 4 of these. And that's why your GPA could drop down a little bit. That's called weighted mean. Or some teachers would say this homework counts 20% of the grade. The exam counts 30%. The final exam counts 40%. So that's a weighted value. Your score times the weight. And that's how you calculate your average. Next time we're going to talk about something called standard deviation. And once we finish with that, we're ready for the first assignment, the first quiz, and plan for the first test.